advent of code with OpenRefine day 10. I've given up on day 9 for now. I could not make that work in OpenRefine. So hopefully day 10 will be better. So the basic problem here is we've got a list of instructions being sent to a CPU, and we have either an add number, which takes 2 cycles, but it's only after the 2 cycles are complete that the register is increased by the value v. And then we have a no-op or noop, which takes 1 cycle and doesn't do anything. So we're going to have a list of instructions, and what we need to do is find the signal strength during the 20th, 60th, 100th, 140th, 180th and 220th. So let's have a look at the puzzle input. So that's the puzzle input. So I did have a look at this previously. I had a look at the at this set of data. So I have worked through this already once. Let's have a let's put those in there, and then what does it call these? These are called instructions. Okay, so this is advent code 9. Okay, so first we can split this on space, and then we've got just trim all that. Okay, so we've got all the no-ops are worth 0, everything else is worth whatever it's worth. So we can add a column. So cycles used. So this will be if it equals noop, it's 0, otherwise it's 2. Oh no, sorry, not if that value. Well, actually, we can say if value equals null. That's the same as it being a no-op. So there you go. Okay, so number of cycles used is that. So we then, what we want to do is work out the value of the register. So they called that x, didn't they? So column based on this column, so it's called register x, and that's the sum so far. So this is a handy trick I learned today. So we can do for range 0 to row index increments of 1, and we'll call that I. We can do a cross of I, that will get the row number dot cells dot. I want to add together the cycles used, no, the instructions too. So instructions 2 dot value. Let me just check what that is. Okay, so that's 30. So That's right. So 0, I think. Yeah, so that gives us, for each row, it fetches everything from 0 to that row. So it's actually one behind where we are. So if we do row index, so the first one wants to go from 0 to, it goes from across the, if we go to +1, yeah, okay, so that's the amount it is. Well, that's the amount it is by the end of the cycle. So by the start of the next cycle. So if we actually do it like this, then that is better because that's the value after that cycle is finished. So I think that'll be right. Oh, I need to sum them together. So let's do that again. So it's that, and then it's sum those. Okay, so yeah, we can see that that's, and then, so this is the value at the start of the cycle, because we don't actually get to 33 until this cycle is finished. So those cycles used shouldn't be 0, they should be 1. So let's just yeah. Okay, that's better. So now our cycles used. So we can actually split these out. So let's transform. So range 0 to value 1 by. So let's do 1. So I'm just splitting these 2 into 2 1s like that, and then we can split this on pipe, and then we can turn this into a number, and so cumulative cycles, and we can use the same trick again. Cycles used. So I can sum that. So we want to, there you go. Okay, so what we want to find out now, if we do a facet, so we want to find this for the 20th, during the 20th cycle, so it's, the value is that times the cycle, so we better work that out. So if we fill down this, that'll all be right, and then we can do add so what do they call it? signal strength. So signal strength, and that's the value times the cumulative cycle value. It's not working. Well, that's not working. Oh, that's so we need to do cells dot value. Okay, and then I want to find, so I want to find these where they're 2060. So that is if we do a custom text facet, and that's plus 20. So is that all mod 40? That's right, so that would be 21. So we want 20th, 60th. So we want it when it's 0 mod 40. 20th, that's it. So, okay, that's fine. And then we've got 6 values. So we can do a let's just do a well, actually, so if we do a transformation on signal strength column, which is the same as we've got here. So instead of cycles used, it's signal strength. For range, and if we do from 20 to, and we increment 40, then we should find so for range. Oh, sorry, we want to go to 240. Oh, we want to start from. Maybe not. We can do it like that. We can say filter and say that plus 20 mod 40 equals 0. It's not quite right, is it? So feel like I'm overcomplicating this. We just want to add those together. So, okay. Right, come on. Record 1. So we sort on that. Doesn't really matter which way we sort it. Let's reorder permanently. Make sure we have a different one there. So let's now change the records and blank that down. And then we can do transform dot cells dot signal strength value dot sum. Hopefully that is the answer. 15760. 15760. Not the right answer. I feel like I probably made a simple mistake somewhere here. Signal strength is the during the 6. So let's just try these. So what if we apply those to here? Okay, so we can check this now. So we should find that the 20th cycle, which is here, value has 21, so that's out. That's not right. Why is that? I know why. Because the register starts at 1, not 0. So all of these need adding 1 to them. That's 1. Okay, so we need to take this back because we need to do that before, well, before we... Okay, and now we can take that one and apply it. Now we can put the facet. that one. We can do 0. So that's the 6. 1, 4. Okay, 16480. Try again. 16480. Yeah, got it. Oh, stupid mistake. Right. Okay. So second part. Needs some reading through. I will have a read and come back to this later. Strength. Okay, so this is Advent of Code Day 10 Part 2. So essentially what we're looking at here is a way of drawing things on a screen, and we were looking at the cycles, and each cycle essentially there's a single pixel drawn, and if that overlaps with the position of the sprite, which is what we've previously calculated, but the sprite is 3 pixels wide, so it's the pixel we previously calculated as the plus or minus 1. And so basically that's what we're trying to work out. The lines are 40 pixels long, so from 0 to 39. So essentially what we want to do is to work out for each cycle where the pixel is being drawn, if that overlaps with the current position of the sprite, and if so, we're going to put in a hash sign, and then we should spell out a message apparently. So first up, I've realised, taking a look at this, that I'd named this project Day 9, but that's obviously wrong. It's Day 10. The position I've got to is all misordered, so I need to step back a little way to get back to a sensible point. Okay, so this is where I think we need to be. We've got the register, which is and the signal strength, and let's just double check this. I think I can ignore the signal strength and just work out the. So it's the register plus or minus 1 is where our sprite is, and if we look at the cycles, then each cycle basically is moving 1 pixel. They're drawing 1 pixel across. So by the time we get to 40, so we go from 0 up to 39, and then we start again. So what we need to do is first of all have a pixel number. So this is going to be the row index mod 40, I think. So 0 through to 39, and then it starts again. So that's right. And then what we want to do is to work out for each pixel number whether that's within 3 of x, 1 of x, sorry, either way. So, and if so, draw a hash. So we have drawing, and it's if value minus no, so we want to do abs of that is less than or equal to 1, then draw a hash character, otherwise draw nothing. So and I think, is it as simple as that? I did do some checking beforehand. Don't think I need the row number, pixel number, that, and yeah. So now if we get rid of everything else, what we can do is, so I'm going to just remove all the other columns except the pixel number and the drawing, and these repeat, so we should be able to use these to make columns, so we can use a transpose. So I think this will, so that'll give us 40 columns wide, and we just need to display all the rows, which is just the 6 of them. And then if I make this small enough, it looks like it says PLEFULPB. So PLEF ULPB. And that's our answer. Excellent, that didn't take long at all.